And we are going to do everything we can to really help them take this to the next level. So let me start from the beginning. And before I even play, understand that the stuff that they are using is some of the items that we used to learn last year, the smart house. And they have converted it and recycled it, added some stuff to it to create what you're about to see. Okay. And so I'm gonna play it, and then if you have any questions for them, ask those questions. But this is to encourage all of us, to be innovative, to be creative, and to find creative ways to use the things around you to create something. Like something like this, somebody can see it and say, you know what, now, and they did a PowerPoint presentation and everything. They didn't just create this, they document their steps, they added their materials, why this and why that, what was the contribution for those materials. They explain every step, by the way. So EBI, we don't just create, we make sure we document. Am I making sense? We make sure we give a reason behind it. We show you the step-by-step approach of how we got to where we need to get. And so you see how Prince, and this is a project that is two people, David Yakubu and Prince Owusu. And the amazing thing is that the two of them are in two different places. They are not on the same campus or the same community, but they have still been able to come together to work. And this is what EBI is about. We, irrespective of where we are, we can still come together to what? Create things for ourselves, our community, nation, and the world. And so let's watch this.
Hello everyone. Hello everyone. My name is Prince, and today I want to present to you our new project that we've done. So this is a spy mini fan, which consists of two buttons, motor. It has a servo that changes the direction, and also a camera. So let's say you have a camera in your room. That will makes your room very safe, because when you're not around, you can spy your room, what's really going on or what's really going inside your room. And also we've built an app that can connect to the fan. So let's say if you are on distance, when the distance between you and the fan is very long, you can use your app to control it. But before we start, let me show you around. So with the app, we have a hole here that serves as a charger. It can charge the fan, or it can give an external power to it. So let's start by plugging a type C cable or charger inside it. So let's do it. The moment you do that, you see that it will on itself. So we will use the switch to control it. Now, the switch, what is that? Is that we've coded that when it is press 1, it on the fan. When it is double press, it speed the fan. And when it is on long press, then I'm talking about the left button, this one, the left one. So let's long press it, and you see that it will on the RGB. So you can see there is light right now, and we can also off it. We can click here to rotate the fan. So feel the air. I can feel the air. It's mind blowing. And let me walk you through to the app that we've built. So before you go on, you have to on your Wi-Fi. So we on our Wi-Fi, the fan will host for us. So there will be a host. So you can see there is EBI mini fan. You click on it, and now boom, you are connected. So after you connect it, you go to our app. So this is our app, mini fan test. You launch it, and you come and see something like this. Let me show you around. This, I'm talking about this. You see this, and then you reconnect it. So you reconnect it, and now boom, you see that they've written connected top there. So you can off the fan right now. So you see I'm controlling the fan here, I can also on it. So let me on it for you to see. I can on the fan and you can see it's coming. I can also on the LED or the RGB, the light. I can on it, you can see the light is on, and then on the fan. It can be working at the same time, and I can change the speed of. So this is how the fan works. This is the app. This is the app of the fan. We've connected it. So what we have to do is to click on the fan, and then the fan will be on. The fan is on now. We can off it, and then we can use the second button to on the light like that, and then we made the app ourselves. I know we always do anything to mix African brides. Just for fun, bro. So we can talk a lot about the app. The app is really, really good. But we know that we will improve on our skills as time goes on. Talks about the facilitators. And then let us off our fan. And then we can off our. So let us off our light. And then the light is off. We can as well use the button, the two buttons. So we can use this one to on the fan. And then when we long press it, it will on the LGB. So in case the app is not there, you can use them. This one works for civil. It will swing the fan left and then the right. But we are still working on that. Thank you. Hope you love it. Let me turn it. Yeah. So it uses charger, the fan, everything, and then the camera. So this is the camera. It spies everywhere. The camera can spy your room in case you are not around. The works. So on the web you can see there is view camera. So when you type on the view camera, it will host. It is waiting for the host. So now we are not hosting anything. I'll do it later. So we can host it, and then you can view around when you are not around. So let's off the fan. Let us off the fan. Let us off the fan. Let us off it. And we've off it. Let us off the light. And then boom. Madam, do you like it?
I hope you guys got something out of it. Let me close this before it plays some craziness. Okay. So with that being said, any questions for Prince and David? Okay, Katora, you can ask your question. Oh, Kweku, you have something to say? Okay. So anybody has anything to add or say? Because I love your you see this case always crack me up. Any questions? Nothing for them? Okay. So one thing that I want you guys to understand is that we are not just here to teach you guys and that's it, right? We want you guys to capitalize on all that we are bringing before you guys. Sometimes you have to, not even sometimes, all the time, you have to learn. You have to try and practice, find different creative ways to take whatever that we are teaching you to the next level. I hope I'm making sense. And so, with that being said, we're gonna do our quiz just so that we understand that you guys get it, right? And then after that, we will continue from where we left off last week from the teaching our machine learning, how we can teach our models to pick up colors, when it comes to fruit colors, when it comes to vegetable colors. Okay, so we're gonna get that. I'm gonna post the link to the files in our chat. So whilst we are getting ready for the quiz, you are also preparing to get your systems ready. And like I always say, we have the stuff on uh, Google Classroom, right? Not Google Classroom, the teachers. We have all the materials in the Google Drive for you guys. So during the week, if you want to go over with your student, you can go over with them. I hope that makes sense. So today's is we have 22 questions. It's not that much. It's the same stuff. Just added one or two new questions for you guys, just to see your understanding. Because guess what? The goal is to be able to help you, and we want to understand you are getting what this whole robotics is about and what the M block is. Because next year we are going to work on another project with the MBOT. Okay, so we are not letting go of it. We're going to add on to it. The MBOT, you can add camera, you can add hands to it for it to move like a human being or whatever, for it to walk and all those things. We're going to add all those add-ons. So we are not done. So the better you understand the beginning or the genesis of the MBOT, the better for you and I, okay? And that is why we are hanging on this. So help us. I know some of you are way ahead of us, but for the sake of those who don't get it, please have patience. Am I making sense? Because EBI, we try to get everybody to what? Be on the same page as much as possible. I know Naima, Prince, what's it called? Chevy team, all of you guys, many of you are way ahead, quicker than them, but let's really work with the ones that don't also get it, okay? And then when they get it, if you know your friend don't understand, please help them. I'm not saying the quiz, but what is like last week, I saw that Kwame Dansu team were helping some, what's it called? Raphael. Raphael was teaching some of his classmates to understand even the parts of the MBAT, which was very nice. Okay. And Uncle Neil will come and explain some of the videos that we reviewed last week. Many of them were wrong. So Uncle Neil will come and explain all the parts and what they stand for. Okay. Because some of you, where the, what's it called? The case, you guys were explaining it in there. Some of you were explaining it very wrong, what the case does. Okay. So we are going to give you that. But before that, let me open the blockade and then we can start. Wait. Okay, hold up. Okay, so guys, if you are playing any game outside of EBI, stop. Please stop. That's not what it is. I haven't given any blocking to play. Okay. Which one do you guys want? Gold Quest, Fishing Frenzy, No, not Fishing Frenzy. Oh,
Fishing Frenzy.
Hey, who was that? It's not real though. Like, this is actual people, like, no. Anything but no. Well, the people that voted. Two people. The link to the is clearly on my screen. Okay. Where can we say people? So we have online. Where can we say people? Guys. Ready? Look at that at the time. At the time. Okay. Yeah, we time. Yes. Be wrong, but. No, I got 3 minutes. You got 3 minutes. Okay, let's do.
They put it like that.
Yeah, it was kind of late.
I'm so tired.
Okay, Naeem, my God. Okay.
There was no yeah.
So you don't know what an M-bot is?
Yeah, I don't know what that about.
Whatever, Rama. Okay, nice. Okay, this one we are going to explain it. Okay, we're going to work on it today. The conditional programming. That's what we're going to work on today. Okay. Okay, yeah, I got that one right. Sorting. Okay. Okay. This, yeah, a lot of you get this one confused. Okay. Okay. So quad RGB sensor, you guys got it right. Good job. Joystick. Okay. Okay. And okay, good job. Okay. Okay. Okay, so what that, yeah, what does AI stand for? Well, Esther, we understand you won't get it. It's fine. Okay. But you get it when you get older. Okay. So guys, today we're gonna be doing the conditional programming, right? The if a, if this, then that. When I press the what's it called? When I press the on button, let this happen. Am I making sense? That's what the conditional in programming. If we're gonna talk about it, but before anything, I would like Anthony to come and then give another overview of the MBOT, since still we have some people who don't get it, because guys, for you to program your MBOT, you need to know where each and what is, because we are going to be using the RG sensor, right? And so RGB sensor, and you need to know what the heck that is. Okay, so the reason why we are so adamant for you to know the system, the parts, so when you are programming, you will know what is going on. Ah, how did this one come out? The ball. Hey, you people. Hey.
Yeah.
Okay, let me stop sharing my screen. Yeah, for the sake of time, we're gonna play the game one time, okay? Because you guys have played it. Okay. Oh, what happened to that thing?
Let me go inside real quick. I'll let them die.
All right. Good morning, everyone, or good afternoon, wherever you are. This is gonna be more like a refresher for some of you. I know many of you already mastered the parts of the. I know many of you already mastered the parts of this MBOT, but there are still a few out there that do not know what each of these parts for the MBOT does. Okay, so we're just gonna take a few minutes to go over it once again. The reason why we are doing this is because this summer is more like the foundation of things to come. Okay, if you don't understand the basics, then next year when we are talking about the add-ons, when we are making this MBOT do some other things, you may get more confused. So we are spending more time to understand the MBOT now. Okay, so first thing to note is that the MBOT is a robot. Okay, it is a robot, which means that it is electronically driven. Okay, it is not something that is manual. Remember, maybe about 2 years ago, we talked about computers, right?
Mm-hmm.
Exactly. We talked about two types of computers. Remember the mechanical computer, right? It is driven by gears and levers, right? Remember that board that we worked on?
Box.
Huh?
Big box.
No, not the big box. That thing that you drop.
The marbles.
Oh yeah. The Turing tumble.
Yeah, the Turing tumble. Exactly. You know, that is a mechanical computer. Okay. Then of course we all used to be other type of computer like laptops. Okay. So today I'm just gonna go over those parts one more time. Okay. The first thing that comes up when you look at the MBOT is this cover. Okay. The cover is the first thing that comes up. When I talk about the cover, I mean this. Okay. This plastic area that has something is very visible inside of this cover, right? We call this cover the MBOT shield, right? So what is it? What's the cover shielding? First thing is that you can see a battery inside of it, okay? So it protects that battery, and also the board, the main board of the MBOT is protected by this shield, okay? So we call it the MBOT shield because it protects the battery and also the main board of this MBOT, okay? Do you all understand that? Do you have any question on this? All right, this next thing we want to talk about is the, okay, the CyberPi, okay? The CyberPi can be removed and it can be on its own. We've not really made use of this very much, at least some of us, right? And what it does is that it acts as a controller for the robot, okay? You can program this CyberPi, right? And use it to control the MBOT, okay? So the CyberPi has a big role. Currently, what we are doing is that we are programming the MBOT through our laptop, and then we are programming the MBOT through our laptop, and then we use either a cable connection or a wireless connection to communicate from our laptop to the MBOT, okay? But at the end of the day, the idea is that we want to be able to control our MBOT from the CyberPi, okay? So it acts as a controller. And like I said, it can be removed or detached, I should say. It can be detached from the MBOT, and then we can attach it back, okay? So on the CyberPi, there's something like a joystick and some other buttons, okay? With the joystick, you can move it around, right, to change direction. And then, I'm sorry, do you have a question? Okay, yeah. And of course, we have the buttons that can stop and start the movement of the MBOT, okay? All right, so I'm gonna attach the CyberPi back to the MBOT. Okay. One other thing I did not mention about the CyberPi is the screen. It comes with a screen. I don't know if you guys can see it. There's a screen here where you can actually upload to the controller. You can upload your code to the MBOT. You can also use the screen to view the settings. Okay, so the screen is very important because that gives you a visual insight into what the CyberPi will be doing. Okay, do you have any question? All right, so let's go over to the main frame of the CyberPi, which we call the chassis. The chassis is painted blue. As you can see, it holds everything together. Okay, the chassis holds everything together. There are several holes around it, and these holes are where you can actually connect the add-ons. So in future, we're gonna have add-ons being plugged into this into all these holes. Okay, you can see there are some holes at the back, and there are some holes by side, and also in the front side of the chassis. Okay, the purpose of those holes is that we will be able to connect hand-ons, like the hands for the robots. We can connect it to some of these holes. Okay, so the chassis basically is what holds all the components together. Okay, you can screw the wheels to it. You can attach the add-ons. The cover also sits on this chassis, so it's the main frame of the MBOT. Okay, any questions? So next thing we want to talk about here is the encoder motors, right? The encoder motors is on the underside of the end board. So you have to flip the end board over to see the encoder motors, okay? Now, we call it the encoder motors because it has the ability, or when it's powered, right, it can operate the wheels, okay? Without the encoder motors, you can't really control the movement of the wheel, okay? And as you can see, there are two, one on each side, okay? So the encoder motors are there so that you can control the movement of the wheels. You'll notice that a few weeks ago, when we programmed the M-board, you can program the M-board to move at maybe 2 is it feet per second, right? Depending on how fast you want, when you program that, the wheels, the encoder motors would rotate the wheels either faster or slower. Okay? Okay, yeah, this is better. Yeah. So yeah, you can see the encoder motor is labeled as number 5, okay, on your screen. Now, as you can see, the way it's pictured here, right, it is under the chassis, okay? Yeah, that is it. So this is what the encoder motor looks like, okay? What I have on the screen is the encoder motors. So, like I said, if you want your wheels to rotate either faster or you want to reduce the speed at which the M-board is moving, this is what is responsible for it, okay? Because this is attached to the wheels of the M-board, okay? All right, the next component we want to talk about here is actually the wheels. Of course, the wheels is very obvious. Can you scroll? The wheels, yeah, as you can see, we have the wheels and then we have the tire around the wheels, okay? So you attach these tires to the wheels, right? You attach the tires to the wheels so that the wheels will be able to move smoothly, either on your on your table or on the floor. Okay, so the wheels are controlled by the encoder motor. Okay. The next component is the RGB sensor. Okay, RGB sensor. From the name, you can know that we are talking about red, green, and blue. Okay, those are the primary colors. And this can be mixed to generate other type of colors. Okay, so the RGB sensor actually senses the color. Okay, so based on the color, you can actually program your M-board to behave in a certain way or to react in a certain way. Okay, so if you want your M-board to move on a straight path, one of the things you can do is have a tape, maybe black tape, and this M-board will be able to read that black color and follow that path to the destination. Okay. So the RGB sensor is responsible for that. It senses the color, and based on what you program, it can react or act on whatever your program says about the picture. I mean, about the color. Okay. Do you have any question on this? Okay. Let's look at the next component will be the ultrasonic sensor. Okay, the ultrasonic sensor. The ultrasonic sensor is it's like the eyes. Okay, it can sense the object. It can sense any obstacle. Okay, so the ultrasonic sensor is also very important as part of the component of the M-board. What else can you tell me about the ultrasonic sensor? What else does it do? Yeah, go ahead.
The robot wants to go towards the, and it can also detect like it's like about to like go off a cliff or something. It can like stop and then like turn the other way.
Yeah, so it's able to sense the presence of an object. Okay, and the good thing is that you can actually program your M-board to sense an object at a particular distance. Okay, so when it senses the object at a particular distance, it can react or it can make decisions based on that. Okay, so if it senses an obstacle that may be 1 foot or 2 feet away, then you want it to make a right turn or a left turn. So the ultrasonic sensor will be responsible for detecting how far that obstacle is. Okay, and then that will be translated to the M-board to make a decision based on that. Okay, I think that is about the components of the M-board. Now there's something I think there's one other thing. These wheels, what is it for? This one here. What is this for? Yeah, go ahead. Huh? Line following. What is this for?
Just go
This senses
of it.
this wheel.
No, it's just balancing
It balances what?
the car. Because if you really think about it, if you just without
If this
that,
wasn't there, what would happen?
the car probably needs to just tilt forward.
If you tilt forward,
Yeah. Oh yes. So yeah, probably tilt forward.
so
It
what
just keeps it
it's
balanced.
like this is like a wheel, okay? Right? It's like a wheel, but it has no it's not controlled by the motor, okay? So all it does is that it enhances the movement of the M-board, especially in the front area, okay? So when the wheels rotate, right, this also rotates, okay? As you can see, the wheels are at the back. Without this, right, the entire front part of the chassis will be hitting the ground, and that will cause some friction. But with this wheel, right, the front side of the chassis is also able to move along with the back of the chassis. Okay. All right. Do you have any question? Can you show the comment in the question?
Any question? The bad. Oh, who was answering the question? Philippa. Oh, okay. Sorry, guys. I don't know why they have this here and I can't see.
Yeah.
I don't know what they did. Yeah.
You can actually measure
The video. I see if I can make it smaller. Because I don't understand why it's selected. Okay, cool. Can we play a game? Please, madam, the link for Victoria, the battery. Okay. And then that's it. I can't see anything else.
Okay. All right.
Raphael, what would you say?
Are there any questions? And don't forget, there is the on and off switch. Okay. There is the on and off switch. Yeah, where you can turn on the okay. So when you're not using or when you're not working with the M-board, you should switch it off to save power. Okay. I know many of you will just leave it on, and the battery will drain. Okay. No, I'm not targeting you. So let's turn it off when it is not in use. Okay. All right. All right. Thank you guys very much for listening.
Okay. Are you guys ready now? Let's, what me for what? Nope. Okay, so I'm gonna share my screen and then always Lima, can I get this please? The microphone. Okay. So before anything, I want to go over this with you guys, okay? Some of you, again, you understand this concept. Others too don't, okay? So I'm coming. I'm gonna, some, like I said, some get it, others don't. So with that being said, let's all work together. Okay. Oh, where's my Canva? Hold up. Very well. Okay. Okay. Share this tab instead. Okay. So guys, before we start, we're gonna talk about algorithm, right? And the reason behind that is that as you guys have gotten to know about the MBOT and its parts, now when we come back to the coding program, you need to know this stuff, okay? And please, I'm gonna share this with your teachers to help guide you. So algorithms are what? A step-by-step set of instructions to solve a problem or complete a task, okay? So we will talk about the condition. This is where the conditioning comes in, okay, Naima, okay? So we started, those who remember our old students, when we started how, when we did the mechanical computer, how we showed you how the marbles were working, okay? And I know it's been a long time, but what I want you to understand is that the step-by-step instruction to solve a problem or complete a task. So before the light is going to turn on, there are step-by-step instructions that the maker of the light bulb has set up, that there need to be some wires connected, and it has to be a switch, right? That when you use that switch, it will either turn on or off. And even that goes with the MBAT. The MBAT has instructions on how it's supposed to what, operate or execute tasks, okay? And so with that being said, when you see algorithms, they are just what, a system or a coding or a programming that has been set to teach whatever device what it's supposed to do when it's triggered by certain behaviors or actions. Am I making sense, guys? If you have any question, I can't see the screen, so you have to ask, okay? If you cannot
So the definition of an algorithm, right, is set of instructions to solve a problem or complete a task. Okay, you need to know this definition, and the reason is that when you are writing your code, or when you're using the block codes, right, what you're actually developing is an algorithm to actually make your robot do something. Okay, so a step-by-step set of instructions to solve a problem. Okay, what is the problem we want to solve during this summer camp?
agriculture, so that a robot can decipher.
What is it? Yeah, what is the problem we want to solve? Because some of you program the MBOT only to dance, right? Is that what we want to do? Okay, so what is the key thing, or what is our goal for the algorithm we're going to develop for the MBOT? Go ahead.
To sort the to sort different colors, like items in different groups.
What did he say? Can you repeat that, please?
To sort different things in different groups based on their color.
Okay, you're saying our goal, yeah, thank you, Kweku, is to have the MBOT sort things, okay? For example, remember last week, we were looking at sorting apples and oranges, right? Yes, using teachable machine, right? So, yeah, thank you, Kweku. That's correct. One other thing is our goal for this summer. Yeah, go ahead.
So basically, the robot to be able to the bridge while carrying like agriculture, something like orange over the bridge successfully.
Correct. So another goal is to be able to develop a step-by-step instruction for the MBOT to be able to move from one point to the other, and also in the path of that movement, we're going to have a bridge, right? The bridge that we constructed earlier in the year, right? So we want our MBOT to be able to do that. So a step-by-step of instructions to solve a particular task. So when you are coding, right, one of the things about, one of the rules about coding is that, you write your codes, right, using set of instructions. Okay, once you are done, you input that instruction into your machine, and then your machine runs that instruction and generates an output for you. So don't forget that word, an algorithm, okay? A step-by-step set of instructions to solve a problem, okay? To solve a problem or complete a task. I want you to understand that, because you're gonna hear that word algorithm, and there are different algorithms, obviously. The project that we saw earlier, right? There are a set of algorithms that were put into that. Okay, they could control the fan from their smartphone, which means that when they press a button, a set of instructions will be passed on to the fan, and then the fan will execute that. Okay, so you can always generate an algorithm to solve a particular problem or task. All right, thank you.
Okay. So our next is coding. I think this is too much. Can I make it? Okay, present. Let me present. So, oh, come on now. Right. Okay. Present. Okay, present now. Okay. So the next thing is on coding. And then for coding, that tells a computer what to do. And what are some of the coding languages that we have out there?
Okay. All right. At least each of you should be able to tell me a coding language that they are aware of. All right. Yeah.
Python.
Python,
Java.
Java,
C++.
C++.
Scratch-based blocks.
Black code, yes. Okay, Scratch.
Is Scratch a coding language? No, Scratch is not a coding language. Scratch is not a coding language. Okay, yeah, go ahead, Agona team. Huh? I'm listening. Let's start the program. Start what? Okay, C+, yeah. Python, yeah. Okay. Java, yeah, we've heard of Java. What else? So that means you guys only know about 4 or 5.
Is HTML one I saw?
Yeah. 5.
Okay.
Okay. So let's understand the meaning of coding. A language that tells computer what to do. You guys know that we also have our own language. Yeah. We also have our own language. Okay. Right? Yeah, go ahead. That's a machine language. Yeah. Yeah, that's what?
Coding.
Okay. Yes.
HTML.
Okay. So a language that tells computer what to do. Right now, the language that I'm speaking that you guys understand is English. Okay. So if I decide to start speaking German, some of you will just be staring at me. right? So when we talk about coding, is a language that we want to write that tells the computer what to do. Okay. Now, when we write a code, yeah, go ahead, Naima. What? Linux. Linux is not a programming language. Oh, yeah. Linux is not language, it's an operating system. Okay, so what I wanted to say is that there are different programming languages out there. When you write a code, for example, using Java, you are actually telling the computer this is what you need to do. But does the computer in itself understand Java? Right? So there's something that will now convert that Java to zeros and ones, which is the machine language. Okay? All right.
So the next thing, you might want me to say, let me go. I'll just go next. If we are just going over to simplify it for them. Wait. Okay, so the next thing on the list is bug.
Okay, a bug. I know some of you love bugs and some of you cannot stand bugs. Okay, so what is a bug? Yeah. Yeah, go ahead.
Okay, it's like something that is. Can I just read this? It's like a
Okay, please get your thoughts together before you read
A
them.
bug is basically a mistake in the code that needs to be fixed. I didn't.
Yeah, she just
basically
Okay. All right. So a bug, right, is a mistake in the code that stops it from working correctly. So when you write codes, right, you're going to run into bugs. You're going to run into bugs. Unlike the real life, in real life, you can run away from bugs. But in this situation, you have to embrace the bug because you need to, because here you need to resolve whatever issue or whatever is causing the bug. Okay, so when you write a code, yes, it's normal for you to run into bugs, okay, within your code. Okay, but you can't abandon it. That's it. That's the thing. You can't, because if you abandon the bug, then your program is not going to run the right way. Okay, your program or your code is going to have issues. That is the reason why you have to take care of the bugs. How do you think you're going to take care of the bugs in your code? You're going to get a bug spray? Yeah, you can get a bug spray and spray the bug. Okay. All right. How are you going to take care of the bug?
Like go through the back, like you go through the code to see what works and what doesn't. Yeah, just run it.
Okay.
See what happens.
Okay.
Probably like you run the code and then what you see that you don't like, what you take out and then replace it.
No, is it what you don't like?
Yeah, well, like what's
No,
not supposed to be there?
What is
Yeah, like what's
causing
causing it?
Yeah, the issue. Esther.
Well, it's not like really like right now. We're talking about like there's two types of bugs. Like a bug, like somebody can listen to you, like that little like black thing, like that somebody can listen to you from your house.
So the bug we are talking about is actually part of the code. Okay, but like I said, you need to resolve whatever that bug is creating. Okay, it could be that, as an example, we all know that 5 plus 5 is 10, right? If you run your code and 5 plus, you said 5 plus 5 is not 10? Huh?
Levi doesn't know that. Levi.
Oh, Levi doesn't know. Levi knows 5. Okay. Okay. 5 plus 5 is 10. Everybody knows that, right? But if you run your code and 5 plus 5 is now 11, that means there's a bug. Or another way to look at it is this. You can write a code to add numbers. That's your code. You wrote a code to add numbers. So, and of course, when you write a code, you're going to test the code. Okay, you run it to test it, right? You can run your code and say, okay, 1 plus 1, and it gives you 2. 2 plus 2 gives you 4. And then 5 plus 5, you got 10. But when you did 100 plus 100, your code said the answer would be 500. That means there's a bug in your code, right, that may not understand when you have 3 digits. Okay, your code may be good for 2 digits addition, but when it comes to 3 digits, it may run into a bug. So when you run into that situation, you need to go back to your code and modify your code to resolve the bug. Okay?
So,
I hope you all understand the meaning of bug now. Okay.
okay. So this one is just by the way so these are the list of programming languages out there. Can you mute yourself, please? Whoever. Yeah. So you see sorry. Yeah.
All right. So going back to the question we asked earlier, that you should list the different types of codes, programming language that you have heard about or that you have used in the past. Okay, this is just some of. These are just some of the codes. So Python is very popular, and your MBOT, right? Even though you are actually using block programming or block code, right? You are moving blocks, but at the back end of the blocks you're moving, it runs Python. Okay, so you'll notice that when you go to the MBOT platform, you have an option there that says, oh, do you want to program using blocks or do you want to program using Python? Okay, so blocks are easier because you can relate to it easily. But at the back end of those blocks, you have Python codes running. And also on that platform, you'll notice that there is an instruction there that says you can actually create your own block. Okay, you can create your own block. And how do you create your own block? You use this Python programming. JavaScript is also a popular programming language. SQL, PHP, C++. There are some that I also haven't heard of. Okay. So Rust, for example, I've not heard of Rust. I've heard of Ruby. I've heard of C. Swift, I've heard of Swift. Golang is something new to me. And there are many more. Okay. Yeah, go ahead. What is what? The oldest one. On this list, it will be the C language. Okay, the C language. Yeah, I've known about C plus or C++ since I was a kid. So this programming language has been around for a long time. Okay.
So this one, the next one, we will go over as you guys get older, but this is just a little tease. Okay, so but this is just a little tease on what a binary is, and so it's gonna be here. What is as you code?
So, okay. All right, can you go to the previous
Okay.
screen? All right. So
Guys,
can you
Please.
listen? Can you listen, please? Okay. Yeah, programming is fun. Coding is fun. Okay. All right. On this screen, we have the word binary. Right? Binary. What does binary mean to you? What do you think binary means? Two. Okay. Yeah. When you hear of the word binary, we are talking about two. Okay.
see what they're saying.
Okay. So earlier, a few minutes ago, I told you guys, right? Computers, the hardware, right? When you open up your computers, all you see is the board, you see some microchips on it, you see the CPU and stuff like that. When you code in, let's say, Python or Java, right? When you write your code, right? Your computer doesn't process your code in that programming language. It actually converts your programming language into binary. Okay? And that binary is represented by zeros and ones. I'm sure many of you have seen what is on the screen here, these zeros and ones. When you watch all these sci-fi movies, right? You see zeros and one, and then you immediately conclude that, oh, they are running maybe a viral, a program that could infect the computer. No, this is how your computers process the codes. So when you write an algorithm, right, the computer takes it and converts it into what we call a machine language. You can go to the next. Yeah. A binary unit is known as a bit. Okay. It is the smallest unit of information that a computer can understand. It is stored in series of zeros and ones. A computer thinks by relying on zeros and ones for all information. Okay? So when you look inside of your, when you look at your motherboard, okay, your processors, your RAM, the memories, okay, they all process that information in zeros and one. And a binary unit is known as a bit. Okay, so we have 0 being represented as bit, and then we have 1, which is another bit. Okay, so when you write your code and you run it, that means there will be thousands of zeros and ones going through all those your electronic components on your computer, inside of your computer. So we just want you to understand that the programming language, right, is written so that you and I can understand what we are writing. Because, please go back. Sorry, go back. Now, if we can write our codes using this machine language, right? If you can write codes using zeros and ones, and you pass that instruction to the computer is going to process it directly. There's no waste of time. Okay? But you and I cannot really relate with zeros and ones. What I mean by that is that if I want to write number 5, for example, right, I can just write 5 and you understand it. But a machine doesn't understand that number 5. The machine has to convert 5 to zeros and ones. Okay? That is why we call it the machine language. Okay? Today, we are not going to talk about how to convert to binary. Okay? That will be for another day. So, but what I want you to understand is that this is how the computer process your code, zeros and ones. Okay? All right, go ahead.
So next is we will move on to this one.
Yeah, more. This is right here. Okay. So I didn't know it's one of the slides talked about this. So the team in Ghana, I hope you guys can understand what I'm saying. Okay. So on the screen here, on the decimal side, and then we have the binary side. On the decimal side is meant for you and I. We calculate using decimals. Okay. Our number system starts from 0 all the way till 9. Okay. So we can relate to 1, 2. Like if I had 1 plus 1, it will give me 2. 2 plus 5 will give me 7, right? And on like that. But a computer doesn't understand the number 2, doesn't even know the number 3 exists, doesn't even know the number 9 exists. Okay. Rather, when you punch in 9 into your calculator, right, the calculator will convert it to binary so that all those components on the board of the calculator, right, will be able to process this, and then it converts it back to decimal for you to get the answer. Okay? So in the computer world, 0 is 0. 1, as you can see, is 1. But when you start getting to 2, you can see it's represented by 0, 0, 1, 0. Okay? I'm sorry? No. In the computer world, this is not 10. It's called 0, 0, 1, 0. No. So, okay, yeah, go ahead. Let me hear you out.
Slide, please. The first digit is 1, and then the second one is 2, and the next one is 4, and then the next one is 8.
Okay, yeah, I understand what you're trying to say. So, guys, listen. All right. Now, in the previous slide, we talked about bit. Bit is a unit. Okay, so this one here is a unit. We call it bit. These zeros are also bits. Okay, now there's something we call byte. A byte is made up of 8 bits. Okay, so 8 bits is equal to 1 byte. And the byte is spelled B-Y-T-E, not B-I-T-E. So you people, I mean, we talk about kilobytes, gigabytes. That is where it came from. 8 bits is equal to 1 byte. Okay, so really, we are representing this binary side with 4 bits. But if you really want to go deep into it, it should have been 8. Okay, 8 characters. Okay, so we have the number 3 as it would be 0000011. Okay, the number 6 will be 00000110. Okay, please do not try to memorize this. Yeah, do not try to memorize this, because if I give you a number like 25 now, and I need you to convert it to binary, memorizing this will not help you. Okay, there is a way you do this calculation. Very, very simple. Okay.
You have a worksheet next week, so you guys.
Okay. Okay.
This is just by the way,
Yeah.
because as you get deeper into programming, these things come in place. Am I making sense? So we want you guys to understand what is really going on behind the scenes. So when your programming is not working and you have a bug, you understand what is happening so that you can go back and fix it. Is that okay? Okay.
All right. So again, to summarize this decimal side is meant for you and I. This is how we relate. Okay. I can talk about 19, 20, 10, 5, 100, and stuff like that. Okay. But the computer doesn't understand anything above the number 1. Okay. So don't be surprised that you type in 500, 500, and the computer will represent it by 011010, something like that. Okay. All right. Next.
So you talked a little bit about bytes.
Yeah.
This is just a little bit. Your dad already explained, so we're not gonna dive. Go ahead, or okay. So just a little facts about binary.
Wow, binary code is the basis of all computer languages. Again, we talk about machine language, which is the language that machine understands. Machine means your electronic devices. Okay. Now, to go further into this, right, you all know that if you don't power your devices, right, nothing is going to show up. For example, your calculator comes with a battery, or it uses solar or whatever kind of the energy source, right? If you don't power it, then it's not going to come up. What I want you to understand is, how did we come about these zeros and one, this binary? This binary actually came from a logic. And logic is what? I'm not talking about Egypt now.
So silly. It's on the screen. If you are paying attention, you will see.
Yeah. So in our devices today, right, we need, at least if you are not generating your energy from solar or battery, that means you have to plug it into the wall, into electricity, right? That electricity is what we use as the 0 and 1. When it is on, right, it represents 1, and when it is off, we represent it by 0. This logic, according to here, I didn't know that was the ancient Egyptians that discovered the binary code. But that is not surprising, though. The oldest university in the world is where? Do you know where the oldest university in the world is where? Is where? You don't know where? In Egypt. And what's the name? Tim in Ghana. I want answers from you, because these Americans don't know. The only thing they know is the White House. Please help me out here. The team in Ghana, help me out. The oldest university is where? Is in Ghana? No, it's not in Ghana. Egypt. And what's the name of the oldest university? No. Yeah, go ahead, Jake. Yeah, Jake Afedi.
University of Babylon.
Ah? University of Babylon? Is Babylon in Egypt? No, it's not University of Babylon. Guys, I'm still waiting for the team in Ghana. I can forgive the team, the American team, because they only talk about White House and this thing. Alexa.
It's not this.
I think it's Morocco.
Yeah.
Wow, that's old.
Yeah.
It's called Al Azhar University.
Yeah.
It was founded in 900. I think I found an older one.
It was
Yeah.
in Cairo. It's not called Cairo.
I think I found What? It's Andrew from 859.
Yeah. Yeah. So yeah. Thanks to Google, the American team have Googled it, and they now provided the answer. So the oldest university is actually in Egypt. So let's go back. So ancient Egyptians discovered the binary code. Okay. Okay. Thank you. Okay, so now that we know that the machine talks zeros and ones, our computers internally they talk zeros and ones. We talked about bugs, okay? And we all know that the bugs we are talking about here, a bug spray cannot fix the issue. So what we have is there's something we call debug or debugging. It means fixing mistakes in the code to make it work properly. Okay. I think it was like 2 weeks ago when we programmed the MBot. We programmed the MBot to actually, when it's backing up, it should make some kind of an alarm to warn people around that, hey, the MBot is backing up and everyone should be at alert. Okay. Some of you programmed that, but instead of the MBot, sending out alerts that using a sound, right? The MBot was actually spinning around, right? It was just spinning at a particular spot. Some of you, when you program your MBot to detect an obstacle and then make a right turn or a left turn, rather your MBot detected the obstacle and still ran into the obstacle. Okay, so those are mistakes that you've made in the programming. So what you got to do to resolve it is to debug, okay? Fixing mistakes in the code to make it work properly is what we call debug, okay? So many times you have to debug your program. You have to debug your code, okay? Raphael and the other guy, what's the name of the other guy that
Prince
and who?
David.
Prince and David, right? They found that they were controlling using their app. I'm sure the very first time they didn't get it right. They had to debug and debug, right? Until they found the issue and corrected it. Okay? So debug is something that you probably will have to do many times. Okay? Debug is probably something that you have to do many times to get your program working. Do not get frustrated when you run a program and it doesn't work the way you expected it to work. It just tells you that you've now moved into another stage, which we call the debugging stage. You have to debug your program to make it work. Do you have any question? All right, let's go to the next one. What is a program? I know we use this word quite loosely. What is a program? A program is a set of instructions written in a code that a computer can follow. Okay? Is a set of instructions. Okay? Remember, a computer, we have to tell a computer what to do. If you don't pass instructions to the computer is not going to do anything. Okay? Remember our definition of a computer, right? A computer is a device that takes an input, right, and processes that input to generate an output. That is what a computer is. It must take an input, or it must receive an input from somewhere, and then it processes that input to generate an output. That is a computer. So what is a program? It's a set of instructions written in code that a computer can follow. Okay? And talk about the code. So I can write set of instructions in Java, in JavaScript, and then pass it on to the computer to process that program, right? And it will generate an output. A complete set of instructions written in code that a computer can follow. Okay? That is what we mean by a program. And a programming language is the language you want to write your program in so that the computer can take that program, process it, and generate an output. Next. All right, sequence. This is also very important when you are writing a program. Okay? Sequence, the order in which steps or instructions are followed. Okay? If you want to go downstairs from here, if you want to go to the parking lot from here, I'm sure you're going to have a sequence. Okay? And what I mean by sequence is that in your mind, you would have thought about how you're going to get to the parking lot. I'm sure your mind would not tell you, okay, come over here and jump through the window to get to the parking lot, right? And your program, your mind, right, is not going to tell you, or your thought is not going to tell you that, okay, when you get out of this door, turn left. Turn right, because there's a wall on the right side. Okay? So the order in which your instruction is going to be processed is very important by the computer. So first step, next step, third step, fourth step, and on like that, until you run the entire program and get the output that you desire. Okay? So sequence is very important. For those of you who also remembers how to solve problems using long division. Okay. Now in long division, if you have to divide a number by, you have to divide the numerator by the denominator, right? One of the things you have to look at is you're going to take the first number in the numerator, then you take the second one, right? You combine it, and then you start your long division. You are not going to start from the last number because there's a sequence, step-by-step instruction of how you're going to solve that long division. So the same thing in a computer programming. There is a sequence that you follow.
When MBOT starts, do this.
Yes.
When you press B, do that. Those are the sequence of actions
Yeah.
that you want it to.
And your MBOT cannot process two things at a time. Remember, we discovered that. It cannot perform two instructions at a time. So it's what we call serial. It goes from the first to the second to the third to the fourth and on like that. So remember that when you are programming your MBOT, you should remember that it takes instruction and run it one after the other. Okay, it doesn't jump. Next. Loop is another thing that you will run into in your programming of the MBOT. What do you mean by a loop? David? Repetition. Is that correct? Yes. When you want to repeat a particular task, you use the loop. Eh? Yeah, it's still repeating a particular task. That's what we mean by a loop.
Okay, guys, this is where you have most of your questions. So
a condition, okay, a rule in a program that tells the computer to do something only if certain thing is true. Okay, a rule in a program that tells the computer to do something only if certain thing is true. Okay, so definitely this is very, very key to our MBOT. The other time, our MBOT, we program it to detect an obstacle. So that is a condition. Okay, it detects an obstacle, then it has to make a decision. Okay, if a particular condition exists, then do this. We program the MBOT to detect an obstacle, and when it does detect an obstacle, that means there is a condition right there. Okay, and then based on that condition, your MBOT is going to do something. Some of you program your MBOT to turn right or left. And when you run your program, the MBOT still did what? Ran into the obstacle. Okay, which means your MBOT did not detect that condition. Okay, if your MBOT did not detect the condition you've described or that you've written, then it's not gonna honor that. It's gonna do something else. So the condition must exist for your MBOT to make a decision. Okay, next. Function, a group of steps or instructions that can be used over and over. Okay, this sounds more like the loop, right? Do you agree? Okay, so what's the difference?
you're a little Roma.
Word is also different.
Oh, Lord.
The slide is also different. The wording is different.
All right, so what did we say a loop was? Yeah.
It's repetition.
Is that what we said?
It goes on, it repeats itself.
Yes. So a loop is when you have a repetition of a task. Okay? So you want something to be performed over and over and over again, you put it into a loop. But now we are looking at a function, a group of steps of instructions that can be used over and over, A function, okay? Now, when we talk about a function, what do we mean by a function? Anyone?
Yeah, well, that doesn't mean my answer is right. I'm trying to.
Yeah, go ahead. Let me hear you.
Oh, like a function could be like if you put, like, if you like put like something in, it comes out different. Like comes out like an input and output.
I think I understand what you're saying. Yeah, Esther.
Like a glitch.
A glitch? No, it's not a glitch.
Wait, am I right with the input and output stuff? Close.
All right, let's try to explain what a function is. Okay, a group of steps or instructions that can be used over and over again. Okay, so a good example of this is that, let's say you want to add the number 2 to a particular number. You want to add number 2 to any number, okay? Or you want to increase a number by 2 all the time, okay? So you have a number that you can represent with x. When you run that number through a function, you want it to increase by 2. For example, your mbot, right? If you want your mbot to move faster, right, you can increase the speed by 2, you can double the speed, you can triple the speed, right? You can quadruple the speed at which it's moving. Okay? So there's a function that runs that anytime, right, you run your mbot into that, through that function, is gonna increase the speed by 2 or by 3. So you have a function that says run the mbot through this function, then the speed will be doubled. If you run it through another function, then the speed will be tripled. You run it through another function, then the speed will be quadrupled. Okay? So a function is steps of instruction that can be used over and over again. Okay? Now, what Naima was trying to say is that in math, we use a lot of functions. So we can have what we call the f of x. Okay? So this is a function. X can be any number. Okay? So you can have, okay, well, we can't write this. This thing is gone.
They open it up.
It's dry. So anyways, you understand what I'm trying to say about function, right? Do you get it?
If the speed is like, let's say 50, and you want to like double that, would be like a function.
Yes. So you run it through that function that will double the speed. Okay. There is another function. So if the speed is right now 10, right? Let's say the speed of your mbot is moving at 10 RPM, 10 revolution per minute. Okay, every minute the wheels move 10 times. Okay, now if you pass it through a function, and that the function is to double the number, to double the speed. So if the speed right now is 10 RPM, when it goes through that function, it's gonna become 20. Okay, that is one use. If the speed was 20, right, and you run it through that same function, what would the speed be after running it through that function? Okay, let me take a step back. You have a function that doubles the speed. That is the function. A steps or instructions that can be used over and over again. So you have a function that doubles the speed. That is the function. It just doubles the speed. So your mbot, right, is running at 10 RPM. When it goes through this function, right, the output will be what? Yeah, it will be 20 because the function is to double the speed. So if the speed was 50, when it goes through this RPM, what will be the speed after running through the function? It will be 100. Do you all understand that? Naima, Rama, do you understand it? You understand the meaning of function?
Yeah.
Okay, and that is why it says you can use it over and over again. So irrespective of what function, what speed you have, once you run it through this function, the function's job is to double. Okay, so if the speed was 100, right, and you run it through this function, the output will be 200. So that function, which is to double the speed, is something you can use over and over and over again. The result will always be that it will double the initial speed. Okay, so if you want the function to, or if you want to triple the speed, for example, if the speed was running at 10 and then you want the output to be 30, are you going to use the same function that doubles? No, you have to get a function that will triple. Okay, and then you can use it anytime you want to triple the speed. You can use it over and over again. We don't really care about what the speed, the initial speed would be. Once it runs through that function, it's going to be tripled. So do you have an idea what function is now? Okay, very good.
We will stop here. We'll go through our machine learning. So
Okay.
next week we will continue. There is more, but these are keywords, okay? Our vocabularies.
Yeah.
Keep talking over till you get it.
There'll be tests on it.
Yeah. So next week when
The
we are
booklet will
doing
be on this.
the blockade, don't say I don't know.
Yeah. Yeah, the booklet will be about this next week.
Yeah.
All these things I've explained.
Function, conditions,
Loop,
loop, sequence, program, debugging, binary.
Okay.
You have to know where binary started from. Yes, because many times people make it look like Black people haven't done anything in this world. So this should let you know that what civilization started from where? Africa. So just let y'all know.
Yep,
It's like
yep.
that. Okay, so now we guys want to take a 5-minute break and then we will come back 5 minutes, and we will come back to our machine learning. Okay? 5 minute break. If you want to use the restroom, somebody, yeah, if you want to go to the bathroom to stretch, okay, get up and stretch a little bit. Get up and stretch. Yeah. Yes, I'm you sitting. Yeah, get up and stretch. Let me stop sharing the screen. Stop.
Stretch time. Yeah, get up, stretch time.
Wait, no stretching now. Stretch time. No, that means that's
Stretch time.
Yep, stretch a little bit.
Mommy,
Get up from the computer and stretch a little bit. We, yes, yeah. What? Oh, please. What? What? She was about to trick me to say yes without even thinking.
Can I have one of the computers?
Stretch.
Can I have one of the computers?
Close your eyes. Open your eyes.
What?
Because
Your eyes are,
she said,
whoever you are. Take a break.
she said yes, I could have. What is it?
I don't know. Whoever is doing
What
it.
the heck?
It's Kweku. Kweku, be very careful, Kweku.
Break, break.
What was it on the screen?
So get your models ready, which is the
I just wink. There you go.
the machine learning. We are about to now teach our machine, okay? You learn about algorithms, you've learned about sequence, you learn about loops, you've learned about many different things today. So as we are working on all those stuff, just think about it. Next week we will add more vocabularies, but today I think we have added a good amount, and all these stuff are good for computer programming, engineering, okay, computer science. They are all good for those things. So don't just say that we are done. We are we are not done. Those who remember, we talked about algorithm before, right? Naima and Rama. Huh? We talked about this before. Many of these things. Yes, it's nothing new. Okay. Okay. It's not going anywhere. We will keep on talking about it. So the earlier you grab it, the better. The better. Let me see who we have on our.
Hey, you want to watch it?
Okay.
What? Did you? No. No, but. Hey, yo, what? That ice cream? Yeah. No, but-
Okay. So let's start. I'm gonna share my screen.
Oh, that's a boy. For timer?
Let's watch it.
I don't see you.
I'm bad at play. I haven't
Wait,
got
look at my screen. That is okay. So.
Okay, guys.
Yeah.
Let's get to machine learning, teachable machine.
already.
Yes. Teachable machine. I'm gonna put the link. I'm putting the link in the chat. Go on there. Last week, I said we did the Canva with images, right? If you need the images, let me know. Yeah.
Yeah, I need help getting on. So I'll have. I'll see.
Why you doing it? Where's your Google?
What do you mean?
I think we're in Google Meet this whole time.
What?
So why are you?
I thought you just said that we're going to take it on the
Oh, please, I changed my mind.
Oh,
Over here.
look at my burning butt. It's so long.
What was the question?
I did four of them.
Can we have?
Remember?
You're not going to play?
You have to send me money. Send me cash.
Donnie.
Chevy people, send me money. I'll send you the slide. I'll have the slide in the teachers resource folder. Okay, I'll have it in there. Yeah. Okay. Stay away from there. I think yeah. Go back. One. So start. Okay. So with that being said, I will have the teachers. There is a resource page. We will add a slide for you guys. If you are not on there, let me know. If you don't have the EBI email, let me know. Or if you can't access your EBI email, let me know, because that's the only way you can access the teacher's resource folder. Just FYI. Okay. So now with that being said, over here with your machine learning, you are going to, so we talked about commands, right? We talked about function. We talked about sequence. We've spoken about programming, debugging, and what's it called? Binary, bug, coding, and all those things. We talked about algorithms. When this happen, let this happen, all those things. So today we are going to train our machine, right? Everything that we are used to doing. Like, what am I going to say? The MBOT is operating because the system has been taught, it has been trained, okay, to behave certain ways when certain buttons are pressed or triggers, okay? So this is what we call the machine learning. Machine learning, AI, they've been with us for years, but now it's more common in our mainstream or everyday life, okay? And so I want you to understand that when there is a keypad at the front of the door, that was programmed. It had to teach the system, somebody had to program it or teach the machine that when you put these numbers in, let the person get access to the room or the building. Am I making sense? Some of you, I don't know, you've gone to some places, they have the door that opens by itself automatically. All those things were what? Trained to behave that way. The light, there are some places that you go and then the light will turn off when there's nobody in there. It's like it's supposed to do a motion sensor. When there is a movement, then it turns on. When there's no movement, what? It stays off. So these are all what? Machine learning, teaching the machine or programming it or coding it, okay? So please understand that we have been working or dealing with machines in all capacity. Even your alarm system, that you program it that when it's 6 a.m., let the machine goes off. Am I making sense? So machine learning or coding and programming has been with us for centuries. It used to be mechanical, and now we are working on it with the electronic and with the whole computer system. Computer system has been with us before our keyboard and all those things came in place. Okay, just understand those facts. Okay, and so today we are going to be working with our teachable machine to be able to give you some commands, okay? So we said that we want the system to decipher or to tell us that this is what apple, this is tomato, this is that, this is it. So before we did that, we had to gather our data. When it comes to training a machine or a model, data is very, very important, okay? If you don't have enough data, your machine will not understand what you are trying to tell it to do. Data is what? So important that sometimes some people can spend years on collecting just data or months on collecting just data. Sometimes you cannot just wake up today and say, oh, I'm going to collect data and I'm done. Yes, even in Ghana, the siren that alerting us to know time yeah. So even in high school, there is some kind of like a buzz that help you guys to wake up and all those things. All those things are what? Machines that have been trained to behave in that manner. Okay. Sometimes when those who have been in cars or drive or see cars, what is it called? The way that you when you're about to make a left turn, right? That you set up your car or your navigator so that it can tell whoever is behind you or in front of you that you're about to make a left turn, right? The traffic light, all those things are what? Machines that has been trained that after 3 minutes or after 1 minute, turn on the yellow light or the red light, okay? So we have been working or been living with systems that has been what? Trained to behave certain type of waste. I hope I make sense. Okay, so with that being said, we have I said data. Your data is very, very important. And when it comes to data too, you have to be careful that you are not being biased. Okay, data is very, very important. And so yes, last week when I was doing the oranges, what did I do? When I was doing the orange pictures, what did I do?
You looked at different ones.
Okay, different ones like what? Green, orange. So to not be biased, right? You have to sometimes research on your information or your data, the information that you need. And what I learned is that yes, America has oranges, right? But in Africa, they have what? Green oranges. So when we talk about not being biased, is that make sure that you are inclusive, that you are adding everybody's information to your data, as long as you know that they're going to benefit from it. Am I making sense? So machine learning, teaching your machine is very, very important. So with that being said, now let me go to my, what's it called? Canva, and get the images. If you need the image, let me know. But I know last week I shared with you guys.
Okay.
I'm already on a Teachable.
Okay, get on Teachable Machine, and we have our images saved already, right? Is there anyone who don't have their images saved for the sake of time? Anyone? Okay. So if you have the images saved, the images that I'm talking about are supposed to be these ones. Let me share this stat. Supposed to be we are using the red apples, the yellow banana, the orange, the green orange, onions, tomatoes. There's these is it 4 different types of fruits and veggies, right? So that's what we have. If you need the image, let me know. But I know last week we worked on everybody saving these images. Are we good? Okay. So now the next thing is, let me share this stat. We have tomatoes, right? You saw tomatoes? So you're going to change the class to tomato, okay? And then we're gonna do another one. We had banana, right? And then you can add more class to it. So over here, I think we had onion, and then another class was, what else do we have? Orange, oh, orange. Okay, so having this here right now, the next thing is now we are going to get our images. So for me, you can click upload. So next week, our teachers, if you can, I will send you a list of stuff that you can bring. We are going to break down our stuff into veggies and into fruit, right? And as Akuni taught us the last time, where you set up the color code, because fruits are mostly red, yellow, orange, and stuff, right? And then veggies are mostly okra, like cucumbers, right? What are some of the green vegetables that we have out there? Green vegetables, what? Cabbage, zucchini, spinach, right? These are all, they're all color coded foods. Okay. Okay.
Lettuce.
What happened? Somebody was saying something.
Lettuce.
Oh, lettuce. Yes, yes. I know tomato is. Some people say tomatoes are fruit. Others will say it's veggie. I'm not here to debate.
It's a fruit because it has seeds.
Oh, okay. Okay. I'm not here to debate with anybody. Okay. Thank you. So with that being said, over here you can choose your images. Okay. Choose your images. And for me, we did, what was the first one? That one was tomatoes, right? So we are going to get our tomatoes. David, be careful.
Are we adding all of the fruits?
Make sure you label them.
Okay, so we equal them.
Yes.
I have six.
Can you help me?
Like, the green, orange. Are you out? 1, 2, 3, 4. Wait, are you No. Why can't we use that? It's a green orange. Do I put them in this?
Yeah. Orange. See? This is how we say we are being
Wait, I
inclusive.
was doing
In
it.
Ghana, in Africa, most of the oranges are green.
This is 6, 5, 5. I was doing it like that. Okay, it's fine. Or should I put them all together? Oh, I have it.
No, just live with it. This is different. So yeah, good job.
What?
Good job. Okay.
What?
Did you guys get it? You see how we have that? We have 6 images for our tomatoes. Okay. And then you can do the same thing for your other categories. Okay. Esther, what are you doing?
Okay, you need to charge your laptop. Let me help you.
Yeah. Wait, no. Are you sure?
No, don't upload it.
Are we good?
Don't upload it.
Anybody have any question? Okay, good. Good job. Okay. So now I'm gonna do my banana. So upload. And next week, when we bring the real fruit and veggies, right? We will now use a webcam to also train, okay? So let's go and then add. So what was that one? Was it banana?
No, I was supposed to come out like that.
See.
I'm trying to upload it.
Okay, so open. Is that okay? Banana. So banana, we had only 2 images, which is not good, but we are trying, okay? And then upload, choose, and what was that? Wait, cancel. What I had was onions. Okay, so upload onion.
I put that wrong.
Okay. So that's our onions. And then now our orange. So
Right here. Well, you're not even wearing any colors. Orange. Maybe it's catching this with t-shirt.
okay, so the next one or the last one I have for me is the orange.
Yeah, mine's.
Okay. Okay. So we have orange and stuff. So now what we are going to do when you finish all this, right? Is now you're gonna click or click train your model, okay? So we're going to do that, train your model, okay? And then what I need, where's my phone? I need my phone real quick. She's already.
It said my orange was a tomato.
Oh, we have to train it. Hold on.
Wait,
It says your orange is a tomato.
I put a picture of orange and it's orange.
Okay, we're gonna train it well. Uh-huh. I should come. I'm coming.
You got this?
Mhm. Yeah, I'm coming. Maybe. Maybe.
I don't know what to put. You should press
Hmm.
You press export bottle. You're supposed to be.
I want to see what you guys have tuned.
Okay.
I've done all of class 5.
Look under the
So,
shirt.
Okay.
so that is, this one, your
I get most tomato and orange. Oh, red is fine like orange. Yeah, red is fine like orange. Okay, now it's a,
now it says an orange.
yeah, the orange.
Okay.
Maybe the way you.
Okay, let's.
Okay. So the
I'm all for.
so over here, right? What we are going to do now.
But Rami, you wouldn't really do
is
You didn't get that?
Close to you. Probably the piano. Huh?
You didn't get that? As an onion?
Yeah. But when I put a purple onion, a purple onion, a regular onion, it says it's either orange or tomato.
well, see, that tells you that your data is not accurate. Am I making sense? Because you don't have any purple on your day? No.
I said my onion is orange.
Says the onion is that orange?
Yes.
Are you even on salad real quick?
Okay, so how do you train the onion? Did you train that it is brown or what?
Madam, where can I find the pictures?
It's still really good.
I think I'm left also.
That's my debate, but it's even orange. Exactly.
Madam, where can I find the pictures for my work?
Who is it? Sorry.
Yeah, sometimes it's the way.
Silver.
Madam,
Thank you.
Whatever.
I want you to get it right.
I think so. Okay, what's in my leg? I have candy. You have. Oh, I'm thinking. Hey, why does this thing here?
Okay, guys. So the other thing that we can do, okay, is once you have, guys, once you have your, when you have your computer here, your phone, right? Somebody asked for the link to the pic. Can somebody help the person? Where are you located? Wait.
It's only.
Gilbert.
Oh, I'm lost.
Okay.
Yes, yes.
Do you guys have the images?
No, last time we used one of the our
See, it works.
Okay.
our seniors last time.
Okay. I'm gonna share the link again so that you can upload, okay? Or you can download
Okay,
them.
okay.
So that's why I'm not going to. Yeah, it worked.
Okay.
I think you
That is a Canva images so that you can download those images yourself.
Yay, mine worked.
Okay.
I think you just got.
So guys, under normal situation, if you want to use a webcam, right? For example, we have. Hold on.
You don't really eat for the
done.
Okay.
Politics. Oh, yeah. Onion.
Okay. So, for example, right, we are going to hold it. We are going to show on our screen to. Okay. Did you see what I just said? So now we have different images of the tomatoes on the screen, okay? On the cell phone. So also use your phone image to also train your model. So
Yeah, I can put it.
okay, and then you upload it over there. Good job. Good. Hey, please.
You got big brain.
Am I making sense?
Middle school power.
Okay. Thank you. I'll give you this very soon.
Newly middle school power. Is that orange? Oh.
12. So there's one orange. There's one. Okay, so guys, another one. We're gonna hold and record this. Okay, another type of tomatoes. Okay, the link. What Isaac? What kind of link do you want?
No, I was the I like this. It's literally saying my orange is a tomato. That's what happened to me. Well, training is training.
Is the the color also matters?
Oh, this one here, right? Oh, this one is orange, right? Yeah, like I go to that's not it. So, and also, but the sauce on it created with yours.
Hey, Mario.
On this.
Yeah, sure.
Well,
Hold it.
Do that again.
Oh, that's good.
I was really watching them.
No fighting.
Yeah, I did.
You guys say sorry.
Be can have it your way.
You
rule. Training the team. When you add new image, you have to retrain your system. Have it your way. I will. Wait, yep.
No, I will.
No, I will. There you go.
This is also debugging. Okay.
Yeah.
When it's not working, you go back there and then you debug again to make sure that it's doing what you want it to do. Sorry, girl. Okay, so I just showed you guys how you can also even use your screen. So in this situation, if I had real tomatoes in my hand, right, I would have used the camera to teach the camera that this is what tomatoes. Okay, are we good? So in this situation, because we have it on saved on our phones or like a picture, I'm gonna just do this, and then I'm going to select or hold to record. Okay, and that's it.
So thick.
Okay.
Wait,
Another one. And
So
what other?
now my tongue is do it. So I usually like pick all my plants and then you just put it out and then it will just grow. So now
It's broken.
yeah. Guys, I'm a banana. Really? I'm a banana.
Okay, so see how we got different images, both pictures and also from the phone screen. Am I making sense? Any questions?
It took so many of it. See
Hey,
this one.
yo.
45 samples.
Yeah, very juicy. But
Thank you, David, for sharing the machine learning, the teachable machine link. Okay, so now
Yes, you.
we are going to go and train our banana images.
that hand works. Really? How do you see the shape from it? I mean, yeah.
Okay. So now let me click on the website, and then you can just cover your face so only your banana is showing.
Yeah. Look at this. Look at this.
Okay, and then another image.
Something's going down. Oh, pull it up.
Okay,
And it was literally working.
and we can get a banana that is open up like a.
Just try to pull it up. Think all of it. Okay. Now it's supposed to look like this. Like this.
Okay, so I'm gonna look for other images on banana. Okay, so
Opera.
okay, so this one banana also, and let me make sure. Okay, hold up, my Okay, so now hold it.
Yeah, but I don't know to work. Because here's the thing though, you needed to repeat to go around.
Okay,
Yeah.
so then the next thing we're gonna do is look for onion.
The real website. Oh, wait, no, I remember.
What you added to
We're
the-
trying to I don't know.
All those other ones you uploaded.
This song is the boys my grade. Huh? What? Brown? Oh, yeah, I remember what you. I don't.
Yeah, I think it's just.
Yeah, I remember, sorry. Like, you know, it was this, it was called.
We are gonna go.
Like, whenever I show like a half slice, it says there's a name. And when I
Okay.
get that, I'll show you.
Okay, so the question is, you put something like this as.
I put the exact photo in orange, but it's still just saying there's.
No, I think there's a problem that this one, you uploaded it through the webcam, right?
It's probably more.
Yeah, so it's taking,
No, they
I
have
think it's some sort of taking.
For real, there you go. Well, you
Grab what you uploaded.
Wait,
That
you
was-
Okay, so it's.
Okay, so
Yeah, remove all those webcam stuff. And then you, everything is uploaded.
You guys supposed to be the. 17-page content, was interactive to the. Not bad. 17-page math test. That's not bad. That's not bad. Mine is 10. Mine is 18. Any questions? Huh? Just pretend like they're taking a test. My tests aren't even hardly hard. How many questions do you usually have on a test? I don't know. I don't know the pages. Usually have like probably one time I had a like test that was like out 40.
okay, let's try and add this one to.
Okay, can you look at what she's doing?
Open the thing.
Mm,
What's happening? Oh, is it working?
Okay,
It looks like it's working. Oh,
What I want you to do is take pictures and upload it. Okay, and then use that to train.
okay, now let's do orange. So, since when it comes to orange, we have it, okay. Okay,
I'm not sure. Oh wait, the webcam.
okay. Oops.
Those you need to take pictures of the webcam. Huh? Or the time you have to, the time. I'm gonna forget about it. No, don't be sure. You don't have to, because then you got like 14 hours.
Okay. So when you have added
So it's not as bad.
as many images as you want, right? The more, when it comes to machine learning training, the more data you have, the better. The more data you have, what, the better. Because, and then one thing also is lighting is very important. Remember how the farmers, how they were sorting out the tomatoes, they were using lights to help them to know whether it's ripe or not. That's why our background images are all white, so that the image will stand out. Okay? Okay, so Esther, you wanna? I think you did. Yes.
So I'm definitely.
Yeah, so now we're going to train.
Mommy, I'm definitely.
No. So let's wait for it to train it.
Mommy.
Mm-hmm.
Hello. I don't know what picture I should use for what. It does look tomato well.
Okay, so now that our model is done, so we're going to now test it out, okay? So let me just test it out and see what it's going to tell me. Okay, so let's bring it. You guys are following. Okay, so do you see? It says 100% orange.
Oh, yeah, I see it.
Do you see it?
Yeah.
Okay. Look. Hold up. 100% orange.
I don't even made it. I don't even actually saw it. See what? Wow. Are you looking? Yeah, I am looking. And I don't know. Well, yeah, we should change it. Oh, good.
Yeah. See, now you didn't retrain her model.
Yeah.
When you update the system, you have to retrain it again.
I just trained it.
Yeah, click train. So anytime you make new changes to your data, you need to train it for it to remember what you put in there. Okay, guys? Anytime you make changes, remember when we are in the block coding, right? When we put in those coding of commands, now we have to upload, right? For it to get into the MBOT to now work. It is the same thing with the teachable machine. When you update your data, you have to go back and train your models. Otherwise, you're gonna get error. Is it working now?
No, it said my word was a tomato. The 7 was 100%. Well, when she
100% tomato.
Yeah,
moves
and I-
but when she moved the picture closer, it changed.
Okay,
Yeah,
so
really
the
camera.
problem with it is too many things around. It's confusing. Your thing is saying you play. See all this is confusing.
Well, I'm not.
Cleaning your data is very important. Otherwise, you're going to confuse yourself. So delete all this.
The reason why it's test is because you can get more stuff. And then she put in the.
You see, even though I took pictures of it.
Okay.
Oh, let me see if I can make it. Oh. You see, there's nothing around it. It's just a white background.
I can look.
Where you have the black, the writing, all those things. What? That is not this. That's not what you wanted the system to pick up. So you're not confuse it. So you have to always make sure that your data is clean. Because if you don't want it to pick up P, then don't put it in there. Am I making sense? Because now you have all this thing, and then when you access it, you are doing that. But before you programmed it, you had all those stuff around it. So make sure that everything around it is clean. There's nothing, and that's why having the white background is good. So if you have to save the file or the picture so that you can have the white background like this, and then you can just focus on it like that. You see? Yeah, it says 100%. But if I move it, see how when I move it, it's now saying tomatoes, banana, because there's so many things confusing it. Are we good? Okay, go and try it again. Any questions for me for today? Next week, we are gonna now use the what's it called? The
MBOT.
Yes. We're gonna use the MBOT and now move this information to MBOT, right? And we will use the color coding sensor, the color sensor to now for it to tell us what it is, okay? I said next week. Okay. Are we good? Any questions for me? So even with this, you can move it, over here, you can do exports, right? You can do export and you can save the shareable link. You can save it or you can download it, whatever it is, just make sure You are not messing it up. You can save it. You can even copy this code for later. Copy it, put it in a Google Doc for later, okay? If not, next week and over here, right? Over here, you can save your project to Google Drive. Are we good? You can save your project to Google Drive if you have already logged in, so that next time we will not do it all over again. It will be a continuation.
We're done for class today?
Any questions for me?
No, I'm good. Steve, are you ready?
Okay.
So this is what they use to train. What is it called? All those systems like the what's it called? MBOT, the automation, automatic systems, all the stuff. If A, then what? B. If when it rains, they say what? It pours, right? So I'm trying to make it simplify it for you guys. Sometimes when it gets cloudy, we say it's about to rain, right? That's the same way. It always some of you set your alarm when it's 9 a.m. Let the alarm ring or whatever. It's the same thing. So we've been using coding, programming, all this stuff in our life all these years. But now we want to be what? The developers. We don't want to be the consumers. We want to be part of the developers. So as I'm showing you all this stuff, you can take it to another level, okay? You can take this to another level. This is just the basic. You can take it another, especially my high school students. Yes. Philbert.
Please, we're able to
you did the teachable machine?
Yes, we're able to do that.
Awesome. Yeah, banana is leading because I have on the yellow.
Mine orange is leading.
Okay. Yeah, so make sure that your system is clean. Your data is clean. You see how my data is? There is nothing around it. Let me see if I can show you. You see, there is nothing. It's just the orange and a white background, so that the system will know.
Okay.
You see how I say 100% orange? Because that is how I train it. But if I do this, it's gonna get confused. So data is very, very important. How you train your system is very, very important. When I come here,
Okay.
another one here. Let me make sure. And he said, what, 100% orange again. In Ghana, we have, we already did the, here. See, tomato. Yep, because there is nothing around it. So don't confuse your data with too much stuff behind it at the background.
Okay, madam.
Yeah.
Because you have so many other things behind it.
So next week we will calibrate this,
Okay.
so that all you will see is white.
Okay.
Yeah.
So that was the problem.
Next week we need to bring fruits and vegetables.
Yeah. Please bring your own fruit and vegetables next week. So you program your. Did I make sense?
Yeah.
Bring your own fruits.
So it will also use Chick-fil-A.
Hey.
If you differentiate between nuggets and this other one. What's this other one called? One that has one that has, yeah. You'll be able to tell us that this is nugget.
Any question? Bye, guys. Take care. Don't forget August 7th.
What was that one?
Burkina Faso.
Oh, the embassy. Is it during the week?
It's a Thursday.
It's Thursday.
I have sleep time.
Any question for me, Team Ghana? Kweku, Qatar, are you guys good?
No.
You guys are
Madam
good?
Letitia.
Uh-huh.
Madam Letitia, please, when you were
Uh-huh.
said you made next week. We do program.
Can you come again, please?
Next week, you told us that. Next week, we'll be doing
Yeah, I said next week. We are going to go back on this one. We are going to go back to the make block, right? Let me share my chat. We'll go back and then come and work over here, okay? For next week. So get ready. But bring fruits and vegetables that you can use to train your machine, okay?
Okay.
You can bring three different or 4 different fruits, like maybe 2 fruit, 2 vegetables, okay? And then we can train it, okay? Yeah.
Okay. Thank you.
Okay. No problem. So, any questions for me? I hope you guys understand that our life is controlled by what? Data. Okay. Jacob, you can talk, please. Jacob.
Please, we want to know. Hello, madam. Good evening.
Good evening.
We have a new member. His name is yes.
Hi, Kingsley.
Madam.
Good evening. Kingsley, what you saying?
Hi, madam.
Hi.
Good evening.
Good evening. Jacob, send his information, okay, to Mr. Achu, okay, and then connect Mr. Achu to your leader in the school, so that we can work together. Kingsley,
Madam, please, you said.
Connect whoever your teacher is at the school. Connect him with Mr. Achu, okay, so that the 2 of them can work together and help you guys.
Okay.
And I hope to see you guys every Saturday when we're having class.
Okay, madam. I'll surely do that.
Yeah, it's nice to see you guys. Were you guys able to do this, or you need help?
Please, we were having some network challenges, so we weren't able to follow.
Okay, it's on YouTube and Facebook on our page, right? Just look for expanding boundaries. Look for expanding boundaries. Let me see.
Expanding boundaries international.
Yes, and when you go click on live, right? Click on the live one. You see today's date, 7/26/2025. You see it over there. Oh, let me share. Okay.
Madam, please share the link on WhatsApp.
If anybody have the link, share with them on the WhatsApp group, okay?
I will share it.
Thank you. Okay, so next, make sure when you click export, right? When you click export, upload your what's called? Copy this. Yeah, copy that and save it somewhere. Copy this and save it somewhere. You can also download, and there's a shareable link over here. You can save, right? And on top of it too, you can save it if you have a Gmail account. we can just click on Save Project to Drive. And you can label it and I'm gonna do TM for Teachable Machine, okay? And then you can save it so that next time you can easily open it back again. Okay, so if I want to open it,
Okay, madam. Okay, madam.
It will be a matter of open project from Drive, right? And I can now open it up over there. Okay, and then you can download it also here. You can save it, download all those stuff, and then you can always add new projects. Okay, you know, add new projects. So that is that. And when you are done and you don't use the webcam, you can close it like that, and the webcam is no longer working. But if you want to have the webcam, you can now have it turned on. Are you good?
Yes. Yes, madam. Thank you.
Okay. So if nothing, next week, okay? Peku and Kitara, it was nice connecting with you on Google Meet. Enjoy your week, okay?
Okay, madam.
Okay.
Okay, say hi to mom and dad for me.
Okay.
Okay.
Bye.
Bye.
Bye-bye. Bye-bye.
Bye.
See you next week.